This last naming system I'm going to show you is actually the stock system, but the way I'm going to explain it should make it work for all the different ways that we name compounds. The reason we have the stock system is because there are, in the middle of the table here, as well as in some other places, elements that have multiple positive oxidation numbers. That means that when they combine with other elements, there's multiple different ways they can do that. I'm going to take cobalt as an example. Please notice that it has oxidation numbers of +1 and +3. So if cobalt were to combine with, let's say, sulfur, if cobalt had a +2, sulfur is -2, they would cancel out and the formula would just be COS. But if cobalt has a +3 and sulfur is still -2, they don't cancel out. So in order to make the electrons work out, the least common multiple of these two numbers is actually 6. So in order for cobalt to give up 6 electrons, you would need 2 of them. And in order for sulfur to pick up 6 electrons, you would need 3. So the formula ends up being CO2S3. These two compounds will react differently, they look different, they may not even be the same phase, although I would pretty much guarantee they're both solids. They may have different colors, but they are completely different compounds, so you don't want to name them the same thing. So when we name things that have multiple positive oxidation numbers possible, like cobalt, we have to say what that oxidation number is. So this system I'm going to show you is going to work for everything. So we're going to name our first thing. I'm going to name this compound here first. So I'm going to name my first thing, which happens to be cobalt. And I'm going to leave a little space, just in case. And then because it is a binary compound, there's only the 2 elements in it, I'm going to change sulfur's last syllable to "ide." Now I want to be sure that you understand that this is cobalt with a +2 on it. So now I'm going to go back, and in between the cobalt and the sulfide, I'm going to put the oxidation number of cobalt as a Roman numeral. Let's try this now for the other cobalt sulfide. So we're going to name the first cobalt, leave a little space, and then sulfide. And again, we're going to use the oxidation number as the Roman numeral. So let's say you didn't know whether or not a compound had multiple positive oxidation numbers on its metal. So I'm just going to make one up here. We're going to say we have MnO. Okay, so I'm just going to follow the same steps I did, but I'll show you how this works for everything. So I'm going to name my first, which is manganese. Again, you can look up those names in Table S if you don't know them. I'm going to leave a space just in case. Oxygen becomes oxide. Now before I go back and actually put in an oxidation number or not, I need to check and see if I need to. The only time that you need to say the number of the oxidation number is if there's multiple positive oxidation numbers. Manganese does have multiple positive oxidation numbers, so I have to say what it is. To figure out which one manganese is, I need to know oxygen. If you don't know, it's -2. It's just in the periodic table. That means manganese must be +2, and that's the number I'm going to put here. Again, as a Roman numeral. Let's try a couple more. Now this one, we have nickel, and then we have chromium, and oxygen. So I have 3. When I see 3, I need to look at table E. So here's table E, and we're looking for the negative half of our compound because nickel is not one of the 3 positive ones. So now here is chromate. That's the polyatomic ion we have. So we're going to name the first nickel. Leave a space, And then remember, we don't change the name of a polyatomic ion, we just put in its name. So now we need to go back and check. Do we need to put in a Roman numeral for nickel? To find that out, we need to look up nickel in the periodic table, and if it has multiple positive oxidation numbers, then we do. Now this time it's going to be a little trickier because we have a polyatomic ion in here, but when we looked up the polyatomic ion's name, you would also see its charge, which is -2. So I'm going to just put parentheses around here, even though they're not necessary this time. That's -2. And there's only one chromate. There's no subscript outside the parentheses. The -2 is on that whole thing. So nickel must be +2. So we want to make sure we know that's nickel 2 chromate. One last example. This one is going to be NaNO2. Okay, so we're going to name the first sodium. And I see 3, so I must have a polyatomic ion. So here it is. NO2 is nitrite. I'm going to make a mental note that it's -1 just in case I need to know that. Nitrite. And now we got to check. Do we need the Roman numeral in there? Let's check. Here's sodium right here. Sodium only has one positive oxidation number, so we don't put the number. In fact, if you put the number when there shouldn't be, you would lose points. That would be wrong.